This crop circle design is a very good fit for 0.9 ratio, but just to look at the mathematics of that, if I take pi, which is here, and square that, I get 9869, square it again, 974, square it again, 9488, square it again, 90, and square it again, 81, square it again, 6561. That's 0.9 ratio according to the crop circles. And they're inverse, so they increase or decrease one way or the other. It's weird the way it works. I can go, take those off, to the square root of 6561, or to be 81. Square root of that, so we're just cutting that down, the square roots here, 9. And we need that to be a 0.9. Otherwise the square root will just go to 3. And square root that, 9486. Now if I take the cube of that, I'll get 8538. And the cube of that is going to equal 622, which is the number that we're looking for. And if I square that, I'll get 387. And if I take the cube root of 387, I get 729. 723 is actually the proportional distance between the Earth and Venus. Don't want that. Go to the cube root, equals 0.9. So that cubed obviously is 729. And then that squared is 531441. And then that squared is 2824, the closing rate of the spiral. That's how the numbers are derived from pi on the calculator. But it might also be worth noting that we take pi times e, or pi e, and that equals 8539, which is very close to 85388, but not quite. And if I square that, and that's Euler's identity. 729, square that, 5318, 5314. So the numbers are around there, but these are rational million-digit numbers. I don't know if you can ever exactly close them down. And I think what the crop circles are doing is just putting them in a ratio that you can calculate from, although it's never really going to be quite what you think it is or what you can measure it as at any given time, because there's always so many millions of decimals on the logarithmic divisions. But anyway, that's 9487 there, it's 9487, that goes to a 0.9, and then we have a 0.622 there to there. Now that's the square root of the difference between the Earth and the orbit of Mercury. So if you took the Earth and you went 622 and then 622 again, you would get 387. They haven't done that. What they've done is to make this circle here the orbit of Earth, and then a 387 reduction to the orbit of Mercury, and then they've gone inside that another 81 and then another 6561. These two measurements, 81 and 6561, have a lot of meaning for the orbit of Mercury. But in the meantime, what does it mean? If you see this perhaps as the heel and toe of a ballet dancer, when a ballet dancer spins with their arms out and then they bring their elbows in, they spin faster. That's called the principle of angular momentum. And in the solar system, the sun has got a missing amount of angular momentum, so that it is not spinning as fast as it should be. And perhaps this twist in the field that's caused by the rotation of the sun is a comment on why perhaps it doesn't have the necessary amount of angular momentum evidenced in the speed of its rotation. And in the meantime, here is the 2824 closing rate spirals plus their inverses arranged at every 30 degrees, and that's picking up the ratios that we have here quite nicely. But onto the orbit of Mercury. The green circle is the orbit of Mercury, and what I'm going to do is take this circle here and reduce that by 6561, and that's going to give me the perihelion of the orbit of Mercury. And if I drop that outside circle at the square root of 6561, which is 81, so 2 81 reductions will equal that 6561, I pick up the minor axis of the orbit, and when I move that into position like so, it's as if that circle just wasn't big enough to make that distance, and so therefore it's got to stretch out a bit to get there. It's trying to form a circuit, an energy power circuit perhaps. But that's very common in the solar system orbits and the extrasolar system orbits. It's called the effect of the ellipse. The square root of the difference between the aphelion circle and the perihelion circle will be the orbit minor axis.